Hi all, so this is a video regarding the second assignment, assignment 2 of CML102. So we are given the following tasks. The first one says we are required to solve and refine the crystal structure using Olex2 software for the three datasets provided. They are the SCXRD data. I'm sorry for I'll try to speak as clearly as possible. My voice is a bit low because I have cold. Sorry for that. I'll try to speak as clearly as possible. The second task is to make a crystal packing diagram using VESTA for each crystal structure that we solve using Olex2. Then simulate powder XRD patterns for each structure. This can also be done using VESTA. Then we'll make a report of these, and then of this report we are making this video. So these are the download links of Olex2 VESTA. And there's also a YouTube video regarding how to, structure solution, how to, solve and refine the crystal structure using Olex2. Now, as per the first task, let me just open. This is the folder, SCXRD data. Here, there are different data folders, data 1, data 2, and data 3. And just open the data 1 folder and we found a file known as hct.ins. We opened that. Olex2 and we clicked on work on the right side. We clicked on work, then solve. This after clicking on solve, you would have got the different atoms scattered in this place. You then click on this down arrow, which will turn up when we click on it. Here we need to check the program is, copied as shell X, because it should not be Olex2. It should be shell X. Then we are going to first of all identify it and then refine it. So in refine we have these options. First of all, the different structures which are given to us. We already given hints for this. These as per So as it can be seen here, the hint for the first structure is hydrochlorothiazide. Now hydrochlorothiazide structure looks somewhat like this. For the benzene ring, there's another ring, and there are these different ligands. So based on this structure, we just characterize each atom. Click on that, then we click on the possible atom. We try to refine at one level using the structure. We then calculate, we get the R. When we click on refine, we get the R factor, which tells us how close our structure is to the original structure. Initially it was 7 point something. Then what we did is we increase the number of cycles from 4 to 8. The R1 decreased further. And then we, use this ellipsoid, the ellipsoid shape for these atoms, which takes into account their thermal energy due to vibration and thus helps us reach a more accurate model. So the R factor decreases even more. And then we add hydrogen, after which we get a very accurate model of 3.88 R factor. We do like this for data 2 and data 3 as well. We go to data 2, go to the .ins file, rml.ins, and through data 3, we go to the rupa file, rupa.ins. Both of these files we open an Olex2, And we follow the same procedure as that of the first. The different structures, the hints given were rulazole plus malonic acid and rulazole plus orthophosphoric acid salt. So this is how a rulazole looks like. Okay. This is how rulazole structure looks like. And this is how, malonic acid structure looks like. So using these two structures, we made this. We made the structure of it. And we defined it further. Depending upon the bond lengths, there can be minor mistakes which we need to, check using the bond lengths, the possible electronegativities. Like an electronegative metal should be connected to a relatively electropositive metal. So using those things, we need to check it. Because that always happens. Like, if you know the structure and you know that there can be a chlorine, but a system identifies it as sulfur just because they both have, very similar, very close atomic number. Such type of mistakes by the system need to be identified and then corrected in order to get a lower perfect value and reach a structure which is closer to the original structure. That orthophosphoric structure looks like this. You already know rulazole structure, like this. A benzene ring, another 5-1 ring, nitrogen, oxygen with 3-fluorine. So we use these structures to make and then refine structures using Olex2. We get this and this structure after possible refinement. After refining, we are supposed to, set this mode from no OCTA to ACTA. I've already done it to ACTA. After doing it to ACTA, we're supposed to refine it. And when we refine it, we get a file with .cif extension. That .cif file has to be opened in VESTA. This is VESTA software, which was already installed during assignment 1. And see, the first one. For the first one, this is how these molecules, they align in a unit cell. This is how they, settle themselves in a unit cell. This is how the different bonds take place, see, bonds between different molecules. This is how they are in a unit cell. We did the same. We just opened the CIF files for RML, the second one, and ROPF. So, that is for, that is just the name. Okay. And like here, orthophosphoric acid and malonic acid. And the different name, the name is rulazole. So, it's just the name for it. We get different structures. Now, what we do is we go to the utilities option, click on powder diffraction pattern, and then click on calculate after clicking on this. And we get the different intensity peaks using the same software VESTA. So we get different peaks like this. This is for the first one. The first one, which is hydrochlorothiazide. Then the second one, which is rulazole plus malonic acid. The third one, which is rulazole plus orthophosphoric acid. This one for rulazole plus orthophosphoric acid. And this one for rulazole plus malonic acid. So hydrochlorothiazide. Then after this, just make the report. Thank you.